All right. Good morning, everyone. How about the others? Yes, we just got 9 students here. How about the others?
Probably held up in attendance taking in the first lesson.
Oh, really? Oh, so this time, the teacher of the first lesson, they are not taking attendance in the last minute before having seen. They do it in reverse, right?
Yeah, I know.
Oh, I see. Just wait.
They're doing, yeah.
Just wait. Doesn't matter. And how about the others? Just wait. 10 only. E3. Say 2, 2, 3. Yep. Cycle 36. 36. Today's date. 2nd of December. All right, 陳景希, are you here?
早晨，先生。
係。初中生。Yeah, present. And
喺度。
Yes. 黃家豪。Where are you, 黃家豪? Not here. 黃俊豪。it's not 胡天明. Why is it 胡天明? And 陳浩希。
Hello.
張家榮。何展鵬。林家齊嘅。麥耀南。潘樂芝。蕭俊熙。Where are you, 蕭俊熙? 黃俊熙。鄭廣威。陳子軒。陳龍王 not here. 潘子軒 not here. All right, so now today we will have a something new, right? What is that? Let me show you the file. And today we are going to do something a bit exciting. Now, altogether we have got 12 students here, and each one of you may need to ask one questions about qualitative analysis, because today you know that next week I'm now going to schedule two coming Thursday and two coming Friday. Okay, while at the same time, but to have the qualitative analysis. Since you guys, I will count from the time where you leave home and go back to Changshawan, and at the same time including your lunch. And it will be a challenging task for some of you that you have to come back starting from 2:30. Okay, can you get my point? So this is Thursday. Now let me put it in the chat box. There will be next in the coming Thursday and Friday. Please choose either one slots to have your QA, qualitative analysis. This will be next Thursday and plus next Thursday and Friday. Okay, we have got two series of QA section. Okay, on inorganic salt. You're going to test it, and the time you need to come back is 2:30. I will start the lab section at 2:30 and 4:30. Okay, is that clear? So you have to choose those options to come back. Okay, to do your QA. And today, yeah, so quite fun. It's because of the fact that you'll be given altogether 8. How many? Altogether we have got 10 unknown samples. 10 unknown samples. And what you have, what your task is to identify 2 of them. Okay, it is the minimum task. If you have enough time and you would like to test more, okay, of course, I will give you a chance. And second, for the choice of those sorts, about half of them is a little bit authentic. Okay, so authentic it can be, for example, sodium chloride, right? Potassium iodide, for example. But at the same time, you will be having a little bit more challenging. Just like sodium carbonate, sodium hydrocarbonate, you know that the chemical property, both of them, they're more or less similar. Yet, if you want to really, you use the practical means to test to make a clear difference between carbonate and carbonate. Okay, it is much different in practice when you compare for those in theory. Okay, theoretically you can distinguish, but practically it's quite hard, I must tell. So that's why here comes the lab session. And there will be more challenging one, such like some cation which can't be easily recognized by using flame test. Even though for those will be known as having a very characteristic color in flame test, that may not be so easy to do. So they will add some complexity to it. No need to mention, I may give you some cations such as ammonium ion, magnesium ion, zinc ion, etc. So that would add a certain level of difficulty to the task. Okay, you have to go into imagine whole thing. And why do we need to ask you to identify two of them? Is because it's, first of all, something about practical sense, you have to do it. But at the same time, you need to give me your logical deduction, which means that you are going to give me a some written deduction. Okay, how will you arrive at the answer? Can you get my point? So this is the whole thing that will make you about 2 hours. Mainly for the testing of the substances, it will cost you the first hour. For the another hour is about the logical deduction. How will you arrive to the answer in terms of written? And indeed, it has been chosen as one of the core part in our SPA. Even though I know that you don't have any SPA this year, I still insist having this. Okay, so I will give you the lab menu after this lesson, and please prepare that. Any questions? Any questions so far?
No, not for me.
No. No. Okay. If not, I will start something challenging. This one. I just see Pong Gahu, you just compared, right? How about the others? What happened to the others? Who else haven't got your attendance ticket? This is the one.
咩少應該飲醉酒啊？咩少應該唔喺度？唉，唔好講啦呢啲。
我哋永遠懷念佢啊。
好啦好啦。
Oh, this is once the thing that we do it for those Form 6 students, 做師兄 okay, long time ago. So I would like to ask each one of you, right, to tell me your, first of all, is your description, how you distinguish one from the other, and second, observation. If you can manage, you may also leave your sentence about the, what I mean is your equation, okay, if you can manage. Okay, is that clear? So to start with, I check from the list one by one, and let me your understanding. The first one, 曾經係is too easy. I will not ask you that. I will do it in reverse. 蔡仲常. Choi Jong-sang, are you here? Please do question 1. And you will be given, can you see that? And you will be given about 1 minute to complete these questions. Okay, either oral or you use written. Okay, since we don't have enough time, I will start the timer. Yeah. Choi Jong-sang, bromine in organic solution. And then, now I will not comment on your work first, okay? Just leave your answer before we come up with the debriefing. 40 seconds left. That's the first question. $20 seconds left. Ethane decolorization solution. Okay. Flash. Okay, I just stop. Yeah. Okay, so what do you think? What do you think about the answer, Marcus?
Do we need to write the equation? He does tell about the difference in the observation, after doing the step, which really allows for the wait. Why did he write ethane for both? Well, that's a little typing error.
Yeah, ethane. So you don't know whether or not it is ethane or ethene, first of all. And what else?
Well,
bromine in organic solution, what is that?
It should be 1,1,1 trichloroethane, the organic solution.
Or you want to give some exact solvent. Okay,
yeah.
So, what one? Let me see. Why can't we? What else?
And
111 trichloro. Oh, one more missing. Chloro, you mean? Check
oh yeah,
again, and then what else?
and it doesn't really have the equation for
Yeah, equations. I know because of the limitation on here this time. No way. I know that. So well, to start with, because of the limitation here, I would focus on the. Sorry, I will focus on mainly on your wordings. First of all, ethane and ethene. I would use bromine. Now, for example, any type, any name of organic solvent is possible. Okay, organic solvent. So it can be what? 1,1-dichloroethane or 1,1-trichloroethane, for example, they are possible. So what my focus is on the observation, you may get ethane and ethene. So for some consortium homework, you just say there is what decolorized bromine. The other one no observation. So first of all, after which one is which? First of all, sorry, which is which? The difference between the two, right? This is the double bond, right? Carbon double bond on all those they are just single bond. So yeah, ethene the decolorized. Decolorized, what is the color? Decolorized is I know it's color change. So what is the original color? What is the original color?
Should be brown, I think.
Brown, orange, yellow. Which one? Which one is possible? Which one can score marks? Orange. Okay, remember why now? So it is what I would like to draw attention to. It is the color. It's from orange to colorless. Orange to colorless for ethene. While for ethane, how will I will say that? No observation. Now, if you want to tell it is no observable change, now that may be better, but the point is for this two type of chemical, one is alkane, one is alkene, the carbon number, yeah, now this is what Marcus have shown it, is the word, the speed of the reaction. Now that two, once I go into bromine, they both indeed have reaction. One is substitution, the other one is addition. It is a matter of speed of the two. So for ethane, they will undergo what? They will undergo substitution. It is a slower step. While for ethene, it will undergo addition, which is a faster step. So you are going to tell there is a color change. Yes, okay, you can, but remember to put the word what and ever rapidly. Do still remember rapidly, and that is the key point. But once I write them rapidly, and you have to tell me this one is also have got decolorization, but that change is a gradual change, okay? They will show the decolorization gradually. So this is what I would like to draw your attention. First of all, the choice of the chemical reagent, bromine in solution or bromine in organic solvent. These two, please choose either one. And you are going to show it very clearly. You cannot tell it is organic solution. Okay, it seems a hybrid, and I can find it quite difficult to comprehend what solvent you're going to use. Point number one. Point number two is about the observation. The proper way to show there is no color change, you may just simply say there's no color change. Okay, or you want to show it such by using another wordings, please use no observable change. Three, indeed, to tell you the fact that these two chemicals having a very small carbon size and molecular size. So what is the consequence? Both indeed they will react with halogens, but undergoing two different mechanisms, two different types of reaction. What I mean is, the first one is substitution, which will react with all alkanes, but it is a matter of speed. It is rather slow. When you compare with addition, it's rather fast. So it will show it in the speed of decolorization. One of them is rapid, the other one is gradual. Okay, you need anyway both will decolorize. Okay, is that clear? Can you get what I mean? Now, so this is what I would like to draw attention to this. Okay, can you get what I mean? How about Chen Zihin? Chen Zihin, are you here? This is first question. Second, Chen Zihin. Chen Zihin, where are you? Do you please have a try on question 2? Okay, 1 minute. The question asks for the chemical test to distinguish propane and propane mono. Chen Ziyin, are you here? Chen Ziyin? Chen Ziyin, are you here?
喺度喺度。
係，見唔見到呢條題目？試試做第2條，知唔知條問題問咩啊？即係條問題問緊你 propane 同 propane mono 點樣分別，識唔識？好，點樣？好，口頭講好冇？試試。首先第一樣嘢要做啲咩啊？第一睇 functional group。Okay, which one we would have the functional group? Jean, okay, propane and propane mono. Which one have functional group? But I will give you some clue for propane. I will write it as this. Propane mono, I will write it as this. Okay, so what will have a functional group? This one, right? So what's next? How you distinguish an alkane and an alkanol? Chen Hao-Hei, are you here?
係。
Yeah, please help.
加 acidify 嘅potassium dichromate 落去。
Acidify potassium dichromate. Okay, yes.
係。
And then
跟住propane mono 嘅話就會 changes color from orange to green.
Changes from color orange to green. Propane mono. How about propane?
No observable change.
No observable change. Is that clear? So the way to test it, thank you, is about the difference in the functional group. First of all, this type of questions, you need to show me the functional group. Second is to spot the difference and you use the appropriate chemical. Okay. How about KMNO4 acidify? Is it possible?
Yes.
Yeah. So what will be the color change?
From purple to colorless.
For which substance? Which organic?
For propane mono.
Propane mono. Now, for the impact suggests that that may be too strong. What in terms of what? What is too strong? What is too strong? Yeah, the oxidizing power. Yeah. So if you use KMnO4, theoretically you can have a decolorization, but finally, for propane, even for propane, there may be some chemical change. Okay, and this is what we don't want. But if you want to compare the speed, propane and propane 1-node, of course, for the propane 1-node, they will decolorize more quickly. Okay, so for this type of questions, please choose a milder oxidizing agent, but at the same time, it will give you a color change. Can you see that? Color change. So this is the key point I would like to tell you, address to all of you. Okay, is that okay? Now, thank you. Thank you both of you. And 何展鵬 number 3. Propane 1-node, butane 1-node and butane 2-node. Question 3. Now, in order to speed up the whole thing, I would like to send, use MnO4, KMnO4 and then minus and then H plus. For this question, for question 3, you mean? So what will be the color change? What will be the color change? So I'll show you the worksheets such that all of you may just open it and retrieve it easier. Yes, KMnO4 is just KMnO4, no negative charge. 2-volt. How about butane 1-node? Should be 1-node. How about 2-volt? No reaction. Do you mean that there is no reaction? How about the structure? Butane 1-node is this. Butane 1-node is that. So this two, you claim that you used KMnO4, this one will react and this one will not react. Because 2-O can't be further oxidized. Why? Why? Secondary alcohol. Secondary alcohol cannot be further oxidized. Agree? Now, what is mean by oxidation? This organic substance that will have so many definition of to show there is a oxidation. Besides adding oxygen, in organic chemistry, very often you look for removal, the loss of hydrogen atom. So because for the group primary alcohol, it can be further oxidized from primary alcohol to aldehyde, or even from aldehyde to carboxylic acid, simply because we have got the alpha carbon, the first connecting carbon atom here, and we would have some hydrogen here. So which means that hydrogen can be removed, or we call it lost, and to have an oxidized product. How about the right-hand side? The right-hand side will get 1, 2, 3, 4 butane. We've got the carbon 2, we've got hydrogen here. So the hydrogen can also be lost, and what will they form? What is that? What is the oxidized product? This is what? It is butanol. So whenever you place any oxidizing agent into the two chemicals separately, finally they also give you a color change. So what should be done next? Is something more difficult. We've got 20 questions to go, huh? I would like to show another guy, Wang Junhei. What do you think?
Add 2,4-dinitro-methylhydrazine to 2 samples, and the red the red dinitromethylhydrazine turns from red to the red dinitromethylhydrazine forms orange precipitate for the aldehyde while there is no observable change for the key S. Sorry. I mixed it up.
Which questions are you referring to?
Question 3. Yes.
Question 3.
The additional step of question 3.
Oh, additional step. What do you mean by additional step? It's not the first step. So what should be the first step?
Add acidified potassium permanganate solution to the samples. And permanganate. The permanganate turns from purple to colorless for both butane 1-O and butane 2-O. And then add Tollens reagent to two samples. The silver mirror forms for the aldehyde from butane 1-O.
Butane 1-O, they will form aldehyde when you add KMNO4, etc. You mean?
Sorry. It should be
So what would be the product? If I use this chemical to react butane 1-O, you mean they will form it as butane now? Is it that? Is it what you just said? Okay, is this using this chemical?
Yeah. Yes.
Yeah.
And we should.
But would they undergo further oxidation? Would they undergo further oxidation?
Only butane 1-O will have further oxidation for KMNO4.
Yeah. So how about the color change? If that is both they will decolorize.
Both will decolor. Of course, both decolorize. And then we've got butane 2-O as ketone, so we should we should add 2,4-dinitrophenylhydrazine.
Phenylhydrazine, you mean? Not methyl,
dinitro.
Phenyl,
yes.
Not methyl, yeah?
To both samples at the red dinitrophenylhydrazine forms orange precipitate for the ketone from butane 2-O.
Oh, I see. You want to show this one? You want to get that the oxidized product to have a further. Okay, well, you may find that too, right? That too may be the oxidized product after adding KMNO4. Yeah. So, if you are just asking for, now theoretically it is possible, because for the right-hand side, it is stopped as a ketone, while the ketone with a carbonyl group. The carbonyl group can be tested. The presence of it can be tested by using 2,4-dinitrophenylhydrazine. They will show a red PBT. Okay, So this the theory will be this. Okay, but the question is it a good method? Analytical simplification from both samples. Oh, I can guess what Marcus Lamb want. They want to be a little bit insist on on testing. The first one must be they stop at LD high, while the second one they will stop at ketone, and you want to test it between LD high and ketone. Do you mean like this? So OCD. How about question 3? If you are just asked for a chemical method, chemical test, what is the key of a chemical method is that I want to make it direct. Okay, so what is the hidden message? Simple, right? The test must be simple and easy to handle. Now, for those procedures just like simple distillation, reflux, etc. Okay, theoretically you can arrive at the answer, but if you take an angle of the chemical test, it is not. The chemists will not commonly use it. Okay, do you know why? Because it's so inconvenient. It's so time consuming. Can you get my point? So my point is that any direct method to make a difference, make a distinguishing between the two. So this is what I would like to point out for question 3. Can you get my point? So thanks for both students, actually. Okay, at least I know that you know something more about chemistry, but it's time to know some more direct method. Anyone who can tell direct method? The one I've just suggested before. It really depends on some of you who have done the past paper. Like one Zach.
Hello.
Yeah, tell me. Any direct method to test to distinguish between butyl 1 and butyl 2. One is the primary alcohol, the other one is a secondary alcohol. So this time I look for direct method. Forgotten. Yeah. You just search it as Lucas reagent or Lucas test, right? The test of it, we call it Lucas test. So what is it about? What is it about? First of all, reagent. Second, observation for both. Third, principle. The underlying principle. Lucas. Okay, all of you, could you please search it now? What is Lucas test? What are the chemicals to be used? Yeah. Very good. Okay. Wayne has got the answer, right? To determine the time of turbidity to be observed. Can you tell me the observation? How about the reagents? Reagents. You use what? Zinc chloride and what? In what? Corn HCl. Okay. So this is what all of you, please mark it down. Zinc chloride solution in corn HCl. Observation. Turbidity, right? Which one will show turbidity and what is the time? Zhang Yaming. Let's split into two, right? Primary alcohol, what will happen? and a secondary alcohol, what will happen? Pong Ga Hao, you just say that tertiary alcohol. What is iPod form test? What's that? 肖俊熙, I cannot comprehend your sentence. Tertiary reaction will bring immediately, but the question is, you are going to compare the primary alcohol and secondary alcohol. Tell me the difference. iPod form test. Huh. Now, remember, though, it is a matter of comparison. Okay, you just imagine the logic should be, you are going to have that two unknown. Okay, you're going to test it, which is which. Can you get my point? So, practically, if you are going to heat it, you heat it together. If you don't heat it, you don't heat it together. You heat it for the secondary for one of the chemical, and it seems that you have got a assumption already. You have got the answer already. That one of them is either is secondary alcohol, primary alcohol, tertiary alcohol, right? So which is not logical. You are going to compare it on the same graph, which means that the treatment should be the same. And based on the same treatment, you are going to compare. Do you understand? 陳景熙, Pong Ga Hao, etc. Can you get what I mean? Yeah, better. Take a look on the both the one which is Marcus and Chen Genhei better, okay, better. So you need not do any treatment first of all, and you're going to compare primary alcohol and secondary alcohol, and you have to wait. Same treatment, okay. You're going to put zinc chloride in corn HCl, for example, at room temp, and not primary alcohol, no turbidity will show it. And the secondary alcohol, the solution turns turbid in how many minutes? Maybe 5 minutes, for example. So this is the key. The principle, please. What should be the principle? What will be the principle? Do we know it? Now, indeed, what is the type of a reaction? Now, indeed, it's a ROH and HCl to form what? RCl and H2O. So what is that? It is the type of substitution reaction. So you are going to check the speed of this substitution reaction, which contributes to the turbidity. Why is it turbid? Tell me. Why is it turbid? Why is it turbid? Is it something insoluble? Not really. Instead, you are going to produce something not mixed with the main solvent, which is what? The aqueous. Okay, the aqueous. So indeed, what you find it, just like Zhang Gawen, you just say that oil droplet. So what is that oil droplet? Tell me. You search it on web, right? Which one is oil droplet? Nice. Marcus have got the answer, right? RCl. Why this one show no hydrogen bond with the aqueous medium, especially for the water molecule, right? So it is immiscible with aqueous solvent, with water. So they will form a very tiny droplet and suspended throughout the whole solution, and you will tell it as turbid. Can you get my point? So in that type of reaction, they will undergo certain type of the speed depending on this order, right? The reactivity, you may think of this way. The reactivity, they will show this order to that substitution reaction. A tertiary alcohol will be faster than a secondary alcohol than a primary alcohol. Can you get what I mean? So this is what you are talking about. And if you want to get to know more about the principle, it is much or more or less related to the carbocation stability. So what is mean by carbocation? So the carbon here and this, and in between one of the steps should be kicking out of this hydroxy group, while for this is, it is carbon and then connect to some other thing else, while the carbon, they will form that 3 bonds only because the OH has been kicked out. And here comes a intermediate, a temporary species, we call it carbocation, okay? You are looking for the carbocation stability between the primary alcohol, secondary alcohol. If you are going to choose, is a tertiary alcohol. And because this one is positive, which means it's highly reactive, there's some minus charge that will react with it. So what I want to make it is a little bit metastable state is by thinking of what makes it more stable. How? The way is to make it less positive. Okay, it's make it less positive. So how? If for some example, if I add some methyl group or alkyl group on that, the more alkyl group on that, they'll make that positive charge less positive. By doing so, you will say that the carbocation stability, they will have that order. Okay. So which means that if you want to talk about this one being tertiary alcohol being much more reactive, it's simply because they want to look for the formation of a tertiary carbocation. Okay, what you think in reverse for the primary alcohol, because they have got one alkyl group. Okay, so the effort is less significant. Now it is a little out of the scope, but don't worry. For the Lucas region, this is what I'd like to introduce to all of you. Okay, for the principal part, don't worry. If you don't understand it, not examined in DSE. Can you get my point? Now this part, not examined in DSE. Okay, because it seems that I may have scared you, right? Too scared? How about the others? Let's take a look. Who else haven't answered anything? How about Wang Junho? Now, because we've got only 8 minutes, 4 minutes to go. How about question 4? Wang Junho. Propane mono and propane nil. How you make the chemical test? Question 4. Wang Junho, where are you? Propane mono, propane nil. Warm the solution with Toland's reagent. Yeah. Okay, possible. Let me add one more point for Benzyl question 3. For auto form test, it's possible. One the solution for tolerance ratio, the one with silver mirror is propanol. About the others. So this is the first step. Second step is about the observation. This. How about this? Silver mirror. Yeah, no color change. No formation of silver mirror. No observable change. So what is the underlying principle? What is the underlying principle? This one is in syllabus. 黃家豪。黃家豪 where are you? Yeah. What is the principle? No. So the principle depends on what? So the Coulomb region. So what is the equation? If you know the equation, you know the principle. Yeah, silver mirror. Yeah, red dots. That's right, red dots. The principle is simply red dots. Aldehyde can oxidize while propanol can be oxidized, okay, by using silver ion, right? But not for propane mono. Okay, now I'll just skip that because some questions, they are more or less similar, but I would like to, because we have got 4 minutes left. So just choose one or two equations, the test in which you want to have a further discussion. Take a look. Now for the, you'll be given that worksheets, right? Which one? How about question 5? Don't worry, if you don't want to say anything, I will continue question 5. This one is worth mentioning. It's also worth mentioning. propanol. Let me choose somebody to answer.陳景熙。陳景熙。Yeah, same above. Yeah, same as above. So this one, this time is silver mirror, while propanol is what? No observable change. Okay. And how about this question? Question 10. I'll give you some surprise. Butanol, propanol. Big gift. Big gift to the chemistry students. Some people we have a recess. Both are ketone. It's different, right? It's different from aldehyde ketone. You know that you lose red dots, and you can tell. How about if both are ketone or both they are aldehyde? Now, for example, you are going to do a chemical test to distinguish between butanone and propanol. I can also ask some similar questions between butanol and propanol. If that is the case, unluckily, what would you think of the answer? Density. Take a look on the question again. Thomas, you use a highlighter for help. Chemical test, please. Chemical test. Molecular size. So, and then determine the rate of reaction. How? When you act so promptly, you mean you have got some idea in mind. So to start with, what chemical reactions you are going to have and what you are going to compare what. Now take a look on somebody's thoughts, just like Marcus. You're going to compare the rate of reaction. The slower one responds to the bigger molecule, but the question comes, which chemical equation you're going to compare? And and also you can give you such a difference in the speed of the reaction. Chen Hao-Hei, don't tell me that simply drawing that two structure it would refer that you have answered the question. So hey, what you just write it down here, and I will just give you so many dots, okay, and you can give you a 0 because you have not heading towards the question. We will need to eliminate many options. So what can be possible? Yep, 2,4-D NPH is too fast for any determination to happen. Yes, that's right. But this time, since time is running short, I can give you some hints based on this. The question is, I use 2,4-D NPH. Some of you will be very surprised, right? 2,4-D NPH, both will react. Both will have what? Both will have a PPT, right? First of all, the spelling. Spelling, first of all. Can you spell the chemical different color? So there will be no any significant relationship between the color and the functional group. Understand? Now, for example, we cannot tell red must be aldehyde or ketone, or yellow or orange, right? There will be no direct relationship between the two. 2,4 hyphen dinitrophenol hydrazine. Yes, that's right. So remember, it is phenol, not methyl, first of all. Be aware of comma, hyphen, etc. So after adding 2,4-D NPH, so what you are looking for? Now this one, it will cost you more time, right? Compare weight of the PPT. Zhang Gaoling. That is the qualitative analysis. Compare the weight of the PPT, which means very often, Chen Ginghei is not boiling point. If you're going to have a PPT, how would you choose boiling point test? Yes, that's right. That is melting point. I am becoming Uncle Roger today. So yes, that's right. That is the answer. You're going to do 2,4-nitrophenol hydrazine for the test. Both they will form PPT, but this time the way to distinguish between the two is not by color. Remember, it's not by color. So yeah. So what is next is to show you what is to first of all collect the PPT or wash it and dry the PPT Okay, if you want to make it more accurate for purity check and so as a melting point check, you need to do what? Recrystallization. That is a very important procedure, right? Recrystallization. Do you still remember that? And what's next? What's next is to check the melting point and compare this with the literature value, okay, from the data book. Now, you may search the web and you may know the difference between the two. Which one has a higher melting point for that Hydrazone product? Hydrazone, it is the 240 mph product. You got Hydrazone. And you can tell butanol or propanol, which is which. Now, what's the principle? The principle is that originally butanol and propanol, they are both liquid, while the boiling point, they are more or less too close. Okay, because I have only got one carbon difference between the two, so the molecular size of that is not so obvious, and which will lead to a much difference into the strength of intermolecular force. Even both of them, we have got van der force and dipole-dipole, right? Mainly dipole-dipole, no hydrogen bond. But once it reacts, both chemical will react with 2,4-dinitrophenylhydrazine. So what will happen? They will form a PBT, and they will rapidly make that a very big molecule. Okay, you know that 2,4-dinitrophenylhydrazine, they will merge with the carbonyl compound to form a bigger molecule. While it's added to this melting point and make it very, very low, high melting point. After purification, you have to purify it, and you're going to check melting point. That two chemical, because of the difference in size, it will make you a more distinctive difference between the melting point. And by doing so, you can compare between butanol and propanol. Okay, is that clear? So I will just stop here and let's check. How many questions have we done? 1, 2, 3, 4, 5, 6 questions. We spent about an hour, just 6 questions. And I do think it's a start. Could you please try to finish the remaining? Okay, and do you want to continue this worksheet in the next lesson? Is it good? Because we have got, it just only cover about 30% of that, okay? Please let me know, yeah? Please let me know that, and you're going to continue this, okay? Could you please, and for Chem 1 students, we will try to finish some other questions to make it full. Okay, can you get my point? So we would, for Chem 1 students, we will continue for some other questions. I will choose other questions to have a discussion. Okay, is that clear? So we, after stopping at organic chemistry, we turn to inorganic, something more tricky, something more challenging. And I don't want you guys to do MC. You better do it MC by yourself, okay? Otherwise, it's a waste of time. It's much better to have a discussion of this. Okay? Questions? What do you feel about today's lecture? You forgot, many of you forgot to give me the number today. Yu Zihou, you did not, you just entered at the stage and you do not know what's happening. Don't just give me a hand. Okay, is that clear? Now, if so, I would stop it here. Okay, for Chem 2 students. For Chem 2 students, and we will welcome Chem 1. Okay, or you want to split the video into half? Is it good? Maybe I split that video into half and I upload it into YouTube, right? So I better close it for a while and I will welcome the Canvas students to come back. Okay, see ya. Bye bye.